Okay. 6.3, adding or subtracting rational expressions. Guys, you know the basic concept. If you have fractions and you want to add or subtract them, what do you have to find? What do you have to find?
Common denominator.
Guess what you have to do with rationals? You need common denominators. Exact same concept, right? Just because they look fancy doesn't mean the basics of math go away. You need common denominators. Now look at that first one up there. Do you have common denominators? Get off. You have common denominators. They're both b's, right? So what do you do with the top? Subtract them. Easy. So 2a minus a minus 1 all over b. Okay, so do the top. What do you do? What do you do with this negative here? What do you do? Get rid of it. 2a minus a plus 1 over b. What's 2a minus a? Distribute the negative. Distributive property. You've been doing it since grade 10. You've done it already now a month. What's 2a minus a? 2a minus a cancels out. So a plus 1 over b. But you're not done now, though, right? You always have to do, when you're talking about rational numbers, you always have to do what? NPV. Okay, so what can b not, what is our NPV in this case? What can b not be? That's funny. Right, NPV, b cannot be 0. What do you think?
Here it goes.
What about this one here? Come on, guys. Are they common denominators?
Yeah.
So can you just add the top? Easy. So 2x plus 8 over top of x plus 4. But then, you have to realize something. Like with fractions, would you ever leave me a fraction as 2 over 4?
No.
No, you always need to reduce. Guess what with rationals? Same thing. Okay, look at the top now. I see a 2x plus 8. What can we do? GCF. Can we take out a 2? Yeah, we can. So we can take out a 2 on the top. What are we left with? X plus 4 over top of x plus 4. Now, why can I cancel those x plus 4s, even though there's a 2 up there? What's the relationship between the 2 and the x plus 4? Multiplication, right? So can we cancel those? Yeah, easy. Like that. What are you left with as an answer? 2. But you're not done. You always got to do the NPVs. But you look at that, you'd say right away there's no NPVs because there's only a 1 over the... Yeah, it's 2 over 1, but you always have to go back to the original to find your NPV. Right, it's negative 4 in this case. NPV, right, x cannot be negative 4. Because if it was negative 4, that would make the denominator equal to 0. Well, it is, but it's going to get more difficult. Because the basic concepts I've taught you, right, are the same. We just work with them different ways. Right? The concepts are still the same. Okay, let's look at the next one here. Okay, now what we got here is we have a plus and a minus. But in this case, are the denominators all the same? Yeah, they are. So what do we do with the top and the bottom? Oh, sorry, what do we do with the top? Yeah, we just plug it together. So x squared plus 3x minus 10 all over top of x minus 2. You're done, right? You go for cake and ice cream now? No, you don't. You always got to make sure your rationals, you can simplify them, right? Look at the top. What do you see? What is it? It's a trinomial on the top. So what are you going to try first? Factor it into 2 binomials. Yep, let's try the top here. X and X. The negative in front of the 10 means the signs are different. We're looking for 2 factors of 10, and obviously it's either 1 or 10 or 2 or 5, that when subtracted give you 3. It's all, more than likely it's the middle ones, right, of those 2. So 2 and a 5. Now, we want it to be positive 3, so where do we put the positive? In front of the 5 or the 2? In front of the 5, because that's our larger one there. Okay, and this is all over x minus 2. Oh, look! What can you do? Cancel! That one and that one. What are you left with? X plus 5. We're done, right? NPV. What can x not be in this case? Positive 2, right? Because if it's positive 2, it makes the denominator equal to 0. It's non-permissible, right? It's undefined. So it's a non-permissible, right? Okay, now, if you notice all those denominators are the same, what are we going to do now? Different denominators. 2 examples. It's interesting. You might notice this now from now on. Now that we're getting into the last part of this course, these lessons take a lot less time because each example takes way more, each question takes a lot longer to do. Because look at that. Yeah. All right, let's go. Next. Did I screw that up or no? Yeah, I did. There it is. All right. Okay. Add or subtract rational expressions with unlike denominators. Okay, so in the past, when you wanted to find like denominators, you multiplied the first one or the second one by something, right? But if you multiply the denominator by something, what do you have to do to the numerator? Same thing, right? If I multiply the denominator by 2, what do I got to do to the top? 2, same number. It doesn't change, right? It doesn't change. Same concept here. So we got an x and a y and an x. So what we need to find is we need to find what our common denominator is. What is it? Now, think about it in the past. If I gave you 1/3 and 1/6, right? 1/3 and a 1/6. What's our common denominator? 6. Could you, if you ever got stuck, take the 3 and the 6 and multiply them together? Could you use 18 as your common denominator? Yes. Is that true? Yes. Right, 1/3 and 1/6. Could you use 18 as your common denominator? It's not the lowest one though, right? But could you use it? Okay. The same thing applies to this stuff. So if I was really unsure about what my common denominator is, could I take x and y and times it by x squared? So what would that be? X cubed y, right? Would x cubed y work as a common denominator? Yes. But is it the lowest? Right? Just think about that for a second. Don't write this down. X cubed y. That would work as a common denominator because both of them, I could multiply this one by x squared, that would get me that, and I could multiply this one by xy, and that would work, right? Is it the lowest though? No. What's the lowest in this case? xy, okay. You sure? Let's double check. Well, that's why we're trying. xy, okay. Well, that one's okay, right? Because we don't have to multiply by anything. But look at this guy. Oh, that doesn't work because it's x squared. Oh, we need at least in there. We need a what? We need at least a square in there, don't we? Let's try that one. Okay. xy. How do we get to xy squared? What do we times this first one by? X. What do we times the second one by? No. Y. Well, it's an x squared already, so we just times it by y to get to that. Okay. Do you see that? Who did I lose there? Who did I lose? All right. Look at this example here. Guys, look at this. 1/3 and 1/6. What's our common denominator? Our LCD is 6. But would it work to do it this way? Could you do 18 over 18? Could you do it this way? Yeah, because it both go into that, right? Does that work? It's not the lowest one, but it would work. Okay, so look at this concept here. I have an xy and an x, right? What happens if I multiply those together? What do I get? X cubed y. So we know xy goes into that, right? We times it by x squared. X squared goes into that, yeah, we times it by xy. That'll work. But is that the lowest? No. Okay. So what you kind of have to do is you got to look at the letters that are involved in here. I have an x and an x squared. Which one's the larger of the two? X squared. And what other letters involved? A y. Okay. That's going to work that way. So let's actually make common denominators based on this, and we'll see what we get. Okay, so I want my common denominators to be what? X, Y. So what am I times in the bottom by? X, and what am I doing here? X squared, what am I times in the bottom by? Y, okay. That's going to give me common denominators, isn't it? X squared Y, X squared Y. Okay? So what's on the top there? So 2X. Now, if I times the denominator by X, what do I do to the top? Times it by X. If I have times the bottom by Y, what do I times the top by? Y. Now, these steps that I'm showing you here, you'll start skipping these right away, right? You're going to jump right to a common denominator. Okay, so what's my common denominator here? So X squared Y. Okay, what's on the top? 2X squared. What's on the bottom here? X squared Y. What's on the top? 4Y. Now, if you've done it correctly, now we've gone back to the questions on the previous page. Do we have common denominators? So what do we do with the exponents? Not the exponents. What do we do with the numerators? Thank you. So 2X squared plus 4Y over top of X squared Y. Now, can you simplify? What's between the 2X squared and the 4Y? A plus sign. So those are two separate terms on the top, aren't they? If you're going to simplify, you have to be able to take something out of the bottom and both those terms. So if I have to take something out of the 2X squared, I also have to take it out of the 4Y. Is there anything I can take out of both of those that I can also take out of the bottom? If I try an X, yeah, an X works on the bottom and the left one, but does it work on the right one? No, it doesn't. What about a Y? Works on the right one, but doesn't work on the left one. Oh, shoot. Sorry? But I'd have to be able to take an X and Y out of the first term and an X, Y out of the second term. You can't take one out of each. Well, there's a 2 out of there and a 2 out of there, but is there a 2 on the bottom? As an exponent, as a coefficient, though. No, so you can't. So is it simplified as much as you can? Yes, it is. Okay. The only thing we're missing is NPVs. What can X not be? 0. What can Y not be? 0. Those are easy MPVs. Anytime you get just plain old variables on the bottom, it's always 0. It's really quite easy. Why would I tell you that when you can figure it out on your own? If you figure it out on your own, you'll actually remember it. If I tell you that, you forget it. Can you take what? Just like that? Yeah, you do that if you want. Doesn't make any difference. Okay, next one. Okay. This one takes lots of work. Lots of space. It's actually easier than you think, but you gotta stay organized. The problem is look at the bottom. What do you got on the bottom of this one? You got a difference of squares for the first one, right? Because you can take the square root of y squared, you can take the square root of 4, and you have a negative, so that's a difference of squares. And the second one is y plus 2. So what do you think the first thing we should do before we can even figure out the LCD is? You got to factor it. You have to factor this. Lowest common denominator. So let's factor the top. Let's factor the top expression here. So what do we have on the bottom of the first expression? What is this? This y squared minus 4, what is it? X plus 2, x minus 2. What's on the top still? Y squared minus 20. That's easy. No, I decided I'd switch letters instead. Yeah, of course it's y. Okay, so they're both y's.
Isn't y squared minus 20
Common factor, I drop a pen.
No, it comes apart. Okay. What about the next one? Y plus 2, what's on the top? Yep.
Y squared minus 20.
Okay, is it? Can you take the square root of y squared? Can you take the square root of 20?
No.
You have to be able to take the square root of the front, the back, and they have to be separated by subtraction. So this one's missing one of the things. Can you pick up that banana peel, please? That's underneath your chair. Now, please. Okay. Now, if you were unsure, guys, if you were unsure of an LCD, if you're unsure of an LCD, would it work to multiply all three of those together? Guys, listen, this is where you're going to screw up. If you're unsure of an LCD, could you take all three of those and multiply them together?
Yeah.
Would that give you a common denominator?
Yeah.
Yes. But is it always the lowest? No. In this case, look, do we have two y plus 2's? So we only need to use one of them. We have a y minus 2, we need that one. So what is our LCD in this case? What is it? Y plus 2 and y minus 2. That's what it is. Look back up here, just so we're clear on that. I'll write even right at the top here. What was our LCD way back up here? What was it? X squared y. That's our LCD, right? Yeah. The biggest mistake you'll make, and I guarantee you'll do this on the test because I see kids do it all the time, is you'll use all three of those as your LCD. Will it work? Yeah, it's a heck of a lot more work. You'll have like way more lines of work in there, right? Always go with the simplest one. Okay, so our two LCDs are as follows. Y plus 2, y minus 2, and the other one is y plus 2, y minus 2. Those are our two LCDs. So I'm going to write them out so I have them right there. You could, like you're talking about actually foiling it out, but don't do that because what can happen is later on when we do this, if it's already broken down into two binomials, there might be something we can cancel. But if you put it back into y squared minus 4, you might have to turn it back into two binomials before you can do any canceling. But you always want to leave it in the simplest form right to the end. Yeah.
I don't understand how you got the LCD.
Well, how many things are right here right now? There's 3. Could we use all 3 if we wanted to? So we could have as our LCD y plus 2, y plus 2, y minus 2. Y plus 2, y plus 2, y minus 2. That would work. But the thing is, because we have 2 of those y plus 2's, we only need to use one of them. So for instance, if we had 3 and a 6, would 12 work as a common denominator? Yes. Would 18 work as a common denominator? Yes. But what's our lowest one in this case? 6. We only need to use the one that they both will go into. This bottom here will go into this one, and this bottom here will go into this one evenly. You'll get the hang of it. Once you start doing these questions in your book, you'll see right away. Okay, now, look at the first one. Do we even need to change the first one? Does it already have a common denominator? Yeah, so we just write it in here. So y squared minus 20. Okay, now, y minus 2. What's the denominator on this second one? Y plus 2. What did we multiply the bottom by to get to here? Y minus 2. So if we multiply the denominator by y minus 2, what do we have to do to the top? Y minus 2. That's what you times it by, right? You have to balance out your rationals. Yeah, you can put it all in the same line if you like. So y squared minus 20 plus y plus minus 2, y minus 2, all over top of y plus 2, y minus 2. Right, you can put it all in one line. Really, it's no different than what we've done. The numbers are a little more complex, right?
That's what y minus q squared.
Y minus...
On the top, q squared. You can just put script.
You could, but what do you want to do now? What's your next step? What do you think? Well, no, you can't cancel because, look, some of you think you can cancel, but what are they separated by? Right? There's a plus there. If you want to cancel from the bottom to the top, you got to make sure you take it out of every single term. So it would work taking it out of this term, obviously, but would it come out of this term, the 20? Would it come out of this term, the y squared? Can't cancel. You can't do that. No, you're not done. Somehow you have to take that top part and simplify it as much as you can. So what? No, that won't work because you can't take a 2 out of anything. What do you see here on the top? What do you got here? Do you see 2 binomials? Could you FOIL those? Okay, let's do that. So let's go here. So we got y squared minus 20 plus y squared minus 4y plus 4 all over top of y plus 2, y minus 2. Right? Basically, I took the 2 binomials at the end and FOILed them out. As long as I did that correctly. Make sure you always got to double check my work here. Which one? The last part?
Yeah.
What's the negative times the negative? Okay, what do you do now? What do you do, guys? C-L-T. Collect like terms. Is this the same rules that you learned in grade 9? Yeah, we did this in grade 9 when we taught polynomials, right? Okay, so what do we get here? So what's y squared and y squared? 2y squared minus 4y minus 16. All over top of y plus 2, y minus 2. Hey, look what you got on the top there by the way. What do you got? You got trinomial. What do you always do with trinomials? What do you always try? Factor them. But before, in this case, before you factor it into 2 binomials, what do you also notice? There's GCF, greatest common factor. What's the greatest common factor on the top? 2. So let's take out a 2. What are we left with? Y squared minus 2y minus 8. All over top of y plus 2, y minus 2. Now what are you going to do with that trinomial? Of course you're running out of room. You're going to factor it into 2 binomials. Y and y. What's the negative in front of the 8 mean? That the signs are different. 2 factors of 8 that when subtracted give you 2. 4 and 2. Oh, this is a tough one, eh? Where does the negative go? In front of the 4 or in front of the 2? The 4, because we want the answer to be negative here, so it goes in front of the 4. It has to be the bigger of the 2. Over top of? Now do you see something interesting? Can you cancel that? Now why in this case can you cancel from the top and the bottom as opposed to the other case?
Bracket separating the 2 from the...
Because it's multiplication. It's all multiplication, right? This is one whole term at the top. This is one whole term on the bottom. So then I can cancel the y plus 2's because they're going from top and bottom. There's no addition signs between them, right? It's all multiplication on the top. It's all multiplication on the bottom. Do you see the difference about why you can cancel in this case and not the last one? Well, okay, what are you left with? We're almost done here. 2, y minus 4, all over top of y minus 2. And you're done, right? You go for coffee. NPVs. Now you're going to do your NPVs, right? Now, remember, you can write it 2 ways. You could put whatever the value is not equal to it, or you could put NPVs and just tell me what they are. Now, when you do the NPVs, do you have to look back to the original equation? Oh, obviously, because we're missing one here now as our final answer, right? So our NPVs are back here. What are our NPVs? Y cannot be... Okay, so our NPVs are plus or minus 2. Or you could say y cannot be plus or minus 2. Either way, you can either do it the NPV way or that way. Don't bang on that person. Don't do that. Don't do that. End of question then. Okay, what do you think? Huh? It's really quite easy if the common denominator is the same. The hard part you're going to find is when they're different. The biggest mistake you'll make, let's just look back here, the biggest mistake you'll make is back here at the beginning, you're going to take all three of these as your NPV. Let me give you a piece of advice before you actually start doing these questions. Please listen, please listen. Before you actually do these questions, before you go and spend all the time doing all these calculations, please make sure your common denominator is in its lowest form. Stop. Double check that. Because wouldn't you hate to do all this work and then realize your common denominator is wrong? Do you have to erase everything? Of course you do. So once you start these questions, stop. Make sure you have the same LCD as the person next to you. If you're unsure, can you come ask me, and I will help you to make sure you have the right LCD? Yes. Because after that, it's really quite easy. Okay? You guys have the rest of the class. You have half an hour, and then all tomorrow to work on this.